Hey guys, welcome back to the channel. Today we'll be solving LeetCode 88, merge sorted array. So we're given two integer arrays, nums1 and nums2, and they're sorted in non-decreasing order. And we're given their lengths respectively, m and n, and we want to merge them into nums1. So we're not returning the merged array, we actually just want to store in nums1, and nums1 already has the initialized places or length to store the extra stuff. So the length of nums1 is actually m plus n. So we can actually just modify it in place. So there's actually two ways of doing this. There's the they're both going to be linear time complexity, but the better one is actually going to have constant space complexity, and the other one has linear space complexity where we store our merged array in a variable and then later set it to nums1 or set nums1 to that variable. But what we're actually going to do is I'm going to show you how to do it in constant space, and we can do that by using a two-pointer technique and starting from the end of nums1 and filling it in from the end. So let's get into the explanation. Now, I know I said that we're using a two-pointer technique, but in my code, I'm actually just going to calculate where every pointer is going to be, so we don't have to store any extra variables. So right now, this is where our pointers would be at the very first iteration. So we're looping backwards from the nums1 array, and we're looping backwards from nums2 array, and we're actually looking for larger values. We're not looking for smaller values, but if we were looping forwards, we would normally look for smaller values. So we're currently at 3 and 6, and we can see that 6 is bigger, so we're gonna add 6 to the end of nums1 and then shift our pointer. And we're also going to shift the pointer of the number that we took, which was this. So we're going to move this one to 5. Then we're going to compare 5 and 3. And we see that 5 is larger. So we're going to add 5 here to where our pointer is. Then we're going to move our pointer again. And we shift this back again. Then we're going to check, is 3 bigger or 2 bigger? 3 is larger. So we add 3. And we're going to move this pointer. Then we check, is 2 larger or is the other 2 larger? And we're actually gonna take this 2. We're gonna prefer this one, so we'll make this 2. Then shift these pointers. Then we're gonna check, is 2 larger or 1? 2 is larger, and we're gonna set this to 2. Even though it's already 2, we're still gonna set it to 2. And now we have finished iterating through this array, so we're actually not going to go further. So our while loop would end here. We're done our while loop. Then we're gonna check at the end, is there anything left in the second array nums2 that we haven't added to nums1 yet? And if it is, we're just gonna basically just set that to the start of the array. So if we had like anything left here, we would append it from the start, not to the end. And then we are done because we don't actually have to check if there's anything left in nums1 because nums1 is what we're changing. So nums1 will always have the smallest elements at the start, so we don't have to even check if nums1 has the pointer for nums1 has finished. We just have to check nums2. So the time complexity of this is going to be linear, or O of m plus n, where m is the size of the first array and n is the size of the second array. And our space complexity is going to be constant because we're actually not storing any extra variables to store the array. We're doing it in place. So let's get into the code now. We're going to keep iterating as long as both of our pointers don't reach the start of the array. And we're actually just going to modify m and n to do this. We're going to subtract from m and n every time we add to our result. And now we're going to check which one is larger. So we're going to index the nums1 array, and we have to do -1 because these are lengths and index start at 0. And we're going to check, is this greater than or equal to nums2? And we're going to do n-1 for nums2. If it is, we're going to append to the end of nums1, and we know the end of nums1 is going to be the length of both the arrays -1, and we're going to set it to the value at nums1. Since we took a value from nums1, we're going to subtract m by 1. And in the other case where nums2 is larger, we're just going to do the same thing, but for nums2, and then we're going to subtract n by 1. And after this thing has finished looping, there may be a case where we haven't taken every element from nums2, so we have to check, has the pointer for nums2 reached the start of the array? If it has not, we're actually going to take every element leading up to n that we have not taken yet, and we're going to add that, or we're going to take every element from leading up to n, and we're going to replace those positions with every element we haven't taken from nums2 yet, just like that. And this should work. Note, you do have to replace the stuff in place, so we can't use things like append here in this case, because that wouldn't actually change the value of nums1, because this is not passed by reference, it's passed by, so it's basically going to make a clone of nums1. So if we change anything using like append, we have to actually index into where this is stored in memory and change it. So let's run our code and see if it works. And there's a small bug. Oh, this should be nums1. Looks like it worked, and as you can see, it's very efficient. This will run in O of m plus n time with constant extra space. Thanks for watching.